Hi everyone, this is Dr. Kiran, working as an assistant professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad, India. Today we are going to discuss clippers. So one of the important applications of electronic devices, and particularly diode clippers we are talking about. So today's overview of today's presentation. So we start with the clipper circuit concept, then what is one level clipper, and we will discuss two level clipper followed by summary. So let us discuss about clipper circuit. So what is a basic clipper? Clipper means adding a DC voltage level to a particular signal. So for example, this is an AC signal. So if you want to shift this signal either positive side or negative side, then we use clipper circuits. So it clip off means removing. So your clipper circuit removes either positive half or negative half. So the circuit with which waveform is shaped by removing a portion of the input waveform. So those are diode clippers. So the applications of these clippers are radar, digital and other electronic systems. So remove signal voltages above or below reference level. So we have different kinds of clippers, particularly positive and negative clipper, biased clipper and combination of clipper. That means both positive side and negative side. So this is one level clipper and two level clippers are there. Okay, so let us see one by one. Positive clipper circuit. So it removes all half cycles. Positive means all positive side, for example, this is your AC signal and positive clipper. If you apply this signal to a positive clipper, so what happens? So all the positive side will be clipped off. So positive portion of the input signal will be removing. So if you consider the positive clipper circuit, so there are different types of positive clippers. Positive series clipper, so that is if the diode is connected in series to the input, then it is called positive series clipper, and positive series clipper with positive reference voltage. So this is nothing but if you apply positive reference voltage, means this is biased clipper. And first one is this is unbiased clipper. Similarly, positive series clipper with negative reference and positive shunt clipper. So positive shunt clipper means unbiased positive shunt clipper in which the input signal is applied or connected to the diode in shunt fashion across the load. So shunt capacitor with a positive reference voltage and shunt clipper with a negative reference voltage. So let us see one by one all these clipper circuits. Positive series clipper with unbiased clipper circuit. So which removes positive half cycles of the input voltage, and all the positive half cycles are removed or clipped off. So if you see this signal, so this is an input signal which is applied to a positive clipper. So this is positive clipper. See here, the diode is connected in series to the input. So therefore the output will be, so here the positive sides of the positive half of the input signal will be clipped off. Hence it is called positive clipper, and that too unbiased positive clipper. So if you see the operation during positive half cycle, so during positive half cycle, what happens? Diode gets forward bias, reverse bias, because this is anode and this is cathode. Cathode being negative, so when during positive half cycle, this is point A or terminal A gets more positive compared to the B. So therefore, in such case, positive is connected to cathode of the diode. In such case, what happens? Diode is said to be in reverse bias condition. So in reverse bias condition, it acts like a open circuit. Okay. So therefore, output voltage across the load resistor will be 0 because nothing will be come out to the load resistor. So no current flowing through the diode. IL is equal to 0. So therefore, we can say during positive half cycle, because of this reason, because diode gets forward reverse bias, there is voltage is 0 across the load. So during the negative half cycle, diode gets forward bias, short circuited, that means short circuited. So whatever the input voltage we are applying, so the output voltage is the output voltage across the load. V0 is the output voltage across the load during the negative half cycle. So here one important point is that, so ideal case, let us consider ideal case. So ideally, so this is input signal. So we are applying to a positive clipper circuit. So what will be the output? So the expected outputs, that means positive halves must be removed. That means this is your actual output. But here, if you observe here, so there is a some portion of the input is clipped off in the output. So this is because of the cut-in voltage, conduction voltage, cut-in voltage of the diode. So here a bit portion of the positive cycle is present in the practical output to the diode conduction. So due to the diode conduction voltage, which is 0.7 volts in the case of silicon diode. If it is germanium, it will be 0.3. So if I consider it is a silicon diode, so the portion, positive portion will be 0.7 volts. So ideally it is from the 0. But here practically, so semiconducting, the silicon element has 0.7 conducting voltage. So or cut-in voltage or reference voltage. So that will be available or present in the output portion. Okay. So this is about positive series clipper. Let us see next one. Positive series with positive reference voltage clipper circuit. The same procedure, so which removes positive half cycles, but only thing we have connected the diode in series to the input, but here across the load, so near the load we have given some reference voltage VR, the two positive reference voltage. So positive voltage reference we have applied across the load and near the load. So therefore the output will be clipped off from with reference to this reference voltage. So if you see here, the output will be clipped off, the positive portion will be clipped off with the reference voltage. So the output will be available. If you increase beyond this reference voltage only, the diode starts conducts. So this is the another type of clipper circuit using positive reference. The same way negative reference can also be applied. So this is positive series clipper with the negative reference voltage. So it removes same positive half cycles of the input voltage. All the positive half cycles are removed or clipped off if you see here. But here what happens? We have hence here the input signal greater than the reference voltage, then output will be appear across the load. So here the series diode is connected in series to the input. So for this input sinusoidal signal, so we have Vm and minus Vm peaks. So what will be the output here? See here. Here we have applied negative reference voltage. So beyond, whenever the input voltage beyond or exceeds this negative reference voltage, then only the diode starts conducting. So therefore we have output voltage from this minus VR. Above minus VR, beyond the minus VR, we will get the actual output. So the portion of the some portion will be reflected in the negative side. Similarly, we have shunt clipper circuit. So total we have 6 types: positive shunt clipper with positive reference voltage, positive shunt clipper with negative reference voltage. So this is also called as negative clipper also. So here also same, it removes, the positive shunt clipper removes. Only difference with the series clipper is, in positive series clipper we have connected our diode in series to the input, whereas in this case the diode is connected in shunt to the input. So if you observe here, this is your diode which is connected in shunt or across the parallel to the load. So here we have two loads, R1, R2, or you can say this is RL, this is R and this is RL. Okay. So in this, what happens during positive half cycle? What happens? Diode gets forward bias. So positive is connected to positive. So this is positive, say. So during positive half cycle of the input, given input, the diode gets forward bias and it conducts heavily. So the voltage, whatever the voltage, so the diode acts as a short circuit. So whatever the input voltage we have applied, so that voltage will be flowing through this diode, across the diode. So that means what? There is no output voltage across the load resistor. So this represents the positive portion will be clipped off. So only you will get minus Vm. So here again there is a cut-in voltage of the diode, that is 0.7 volts. So this is the practical representation of the clipper circuit, clipper output. Okay. And now we can also have this kind of shunt clipper with different references voltages. So here you can observe here, during negative half cycle what happens? So during the negative half cycle diode gets reverse biased. That means it acts like an open circuited and the circuit behaves as a voltage divider. So this is very important. So voltage divider means here the output voltage is RL by total resistance is R plus RL. Otherwise we can write this as output voltage V0 is equals to R1 by R1 plus RL. Okay, or you can say R2. So we have represented here load resistor as R2. So V0 is equals to R1 by R1 plus R2 into the maximum voltage of the input. So peak volt, this is called peak voltage or maximum voltage. So therefore we can say that generally RL, load resistor, is very much greater than the series resistance. This is series resistance or source resistance. So RL always greater than RS, source resistor or series resistor. So therefore we can neglect. So then what happens? The output will be minus Vm. The output will be minus Vm. So this is the process to get the clipped output. Now let us see positive shunt with positive reference voltage. It removes positive half cycles again. So during positive half cycle diode gets forward bias, but there is a reference voltage here, positive reference voltage. So whenever you have positive reference voltage, so it will be added and then that portion will be clipped off or removing. So here initially we have cut-in voltage 0.7 and plus reference voltage. For example, this is 2 volts. So 0.7 plus 2 volts will be clipped off. So that means this will be VR will be 2.7. So total 2.7 will be clipped off. So this is the portion, this is the actual output of the practical output of the positive clipper with the positive shunt clipper with positive reference voltage. So here we have applied positive reference. In the same way, we can also have with negative reference also. So let us see that one also. Positive shunt clipper with negative reference voltage. So again, this is a positive shunt clipper and diode is connected in shunt to the input, and we have applied one reference voltage that is in negative reference. So minus is applied. So here during positive half cycle, diode gets forward bias, but the reference voltage is there. So beyond the reference voltage only the diode starts conducting. So hence we have the negative portion, the positive portion will be clipped off and the remaining will be from minus VR, reference voltage. So that means, for example, this will be 2 volts, minus 2 volts, VR is equal to minus 2 means, and there will be a 0.7 cut-in voltage is there. So 0.7 minus 2. So it is approximately minus 1.3 volts. So you have to add this one, 0.7. So minus 2 volts plus 0.7, it will be minus 1.3. So from minus 1.3 up to minus 1.3 from VM to minus 1.3, positive VM to minus 1.3 volts will be clipped off and remaining portion will be remains. So this is the overview of positive shunt clipper with negative reference. So these are very important in the case of radars and many digital electronic circuits. Okay, so that's all for today's session. So let us have some summary of this today's session. So we have discussed what is clipper circuit concept. So clipper means adding DC level to a particular signal. That means if you want to clip any portion, either positive portion or the negative portion, we can use clipper circuit. And types of clippers, so we have shunt clipper, series clipper, and shunt clipper with positive shunt clipper with positive reference voltage, shunt positive clipper with negative reference voltage. Similarly, positive series clipper with positive reference voltage and positive series clipper with negative reference voltage. So most probably the next topic will be on clamper circuits. So if you complete this clamper circuit, if you cover this clamper circuit, our second unit will be completed. So we will most probably next topic will be completed soon. Thank you.